Kia ora, Year 11 and 12. This is the second of the Algebra readiness check sheets that I emailed out to do over the holidays. In this video I'm just going to get through questions 1 to 3. There'll be a separate video for questions 4 through 7. Okay, 6 equations to solve here. First one goes like this. Right, I'm going to multiply both sides by 2, so I get 10 into 3 minus x equals 3x plus 4. Expand the brackets, 30 minus 10x equals 3x plus 4. Now that gives us 26 equals 13x, and x equals a lovely round 2. There we go, x is 2. I'll pop in some more slides to do the next 5 equations. Alright, so 1b, we have x minus 1 over 3 minus 2x plus 1 over 5 equals 2. Remember that there are invisible brackets around here, so it's always a good idea to make them visible. I'm going to get myself a common denominator here. I'm multiplying the x minus 1 by 5, and I'm multiplying the 2x plus 1 by 3. So it looks like that. Now, I'm going to do 2 things at once here. Not always a good idea, but in this case I'm going to multiply both sides by 15, and I'm going to expand the numerator here. So we get 5x minus 5 minus 6x minus 3 equals 30. Collecting up like terms, negative x minus 8 equals 30. Negative x equals 38. X equals 38. Negative 38, sorry. Now a good thing to do is always to check it back in to the original equation. So let's see what we get. Well, negative 38 take away 1 will give me negative 39 over 3 minus 2 times negative 38 is negative 76 plus 1, negative 75 over 5, which is negative 13 plus 15, which is 2. So I'm happy with that one. On to 1c. Okay, 3 to the power of x equals 30. I've got x as an exponent, so I need to take logs of both sides. Using my log rules, I get x log 3 equals log 30. X is equal to log 30 over log 3. Now just before I put that into my calculator, let's have a look at this equation at the start. 3 to the power of something is 30. Well, I know that 3 cubed is 27, so my answer should be just a little bit bigger than 3. And sure enough, when I put it into the calculator, I get 3.0959 for decimal places. 1d. X plus 5 squared equals 16. So there are 2 ways to solve this. The first way is using the squared form directly. If I take square roots of both sides, I get x plus 5 equals the positive or negative square root of 16. So x plus 5 is equal to plus or minus 4. So we have 2 equations to solve. X plus 5 equals 4, or x plus 5 equals negative 4. This one, the first one, gives me x equals negative 1, and the second one gives me x equals negative 9. So 2 solutions working that way. It's good to be comfortable working with taking square roots, but if you're finding algebra really difficult, you need to be more confident doing it the other way, which is where we expand the expression first, and we get this. Now this just looks like a nice easy quadratic, which is what it is. So we have x squared plus 10x plus 9 equals 0. And we can factorise that. into that, and that will give me x equals -1 or x equals -9. Either of those methods is fine. Sometimes when you're working on harder problems you may end up in this form, and it's good to be able to use it confidently. Okay, 1e, 2x squared plus 3x equals 5. Rewrite it first. 2x squared plus 3x minus 5 equals 0. So let's take a look and see if we can factorise it easily. It's a good candidate for doing by inspection because I've got a prime number here, 2, and I've got a prime number here, -5. That means there aren't many combinations to examine. So let's pop down a 2x here and an x here. So I'm looking for two numbers that multiply to give me -5, but add to give me 3. So if I try the -5 in here, and the +1 in here, that's not going to work, but this will work. So let's take a wee look here. 2x squared plus 5x minus 2x will give me plus 3x minus 1. So we're done, but we haven't solved yet. So we have 2x plus 5 equals 0. So either that is true or x minus 1 is 0. So x is equal to -5 over 2, or x is equal to 1. Okay. 1f. Solve ax squared minus bx equals 0. There's nothing bad about this except that the coefficients are now a and b. We've still got our usual things to look for. We're going to look for a common factor. Common factor in here is x. So x times ax minus b equals 0. X equals 0, or ax minus b equals 0. Ax equals b. X equals b over a. So these are our two solutions to that quadratic. Okay, question 2 is about Tom shooting an arrow into the air from the roof of his house. And the height is given by an equation. The equation is this one here. H is equal to 5 plus 30t minus 5t squared. So it's a parabola, it's an upside down parabola, and we're asked how long does it take for the arrow to hit the ground. In other words, we're solving for h equals 0. So 5 plus 30t minus 5t squared equals 0. We're going to multiply that through by -1 to get us a nice positive coefficient. Now we can take a quick look at that, but we pretty quickly figure out that that doesn't factorise very well. So it hasn't got integer solutions. The only combination here is 5 and -1. So we give up on that and we turn to our trusty quadratic formula, which is x is equal to -b plus or minus the square root of b squared minus 4ac on 2a. Right, I'm going to need a new slide to finish this off. Right, so my equation is 5t squared minus 30t minus 5. A is 5, b is -30, c is -5. T is equal to 30 plus or minus, now -30 squared, 900 minus 4 times 5 times -5 over 10. So t is equal to a negative solution, or t is equal to 6.162278. Right, now the negative solution is not on my piece of paper in front of me, but you should write it in there. So it's negative something, which is sitting on my computer here at home. I haven't got it. We ignore the negative solution because we're looking for an answer in context. We're asked how long it will take the arrow to hit the ground. So we ignore the negative solution. Doesn't make sense. It will take the arrow. I need a new slide because I want to write this out properly. it will take 6.16 seconds to 2dp for the arrow to hit the ground. Right, last question in this video. I'm trying to keep it not too long in case you're falling asleep. We're asked here a question about the value of a computer. It's given by this equation. And you can think about this equation as looking something like this. We'll do a bit more of this in wrapping. But here we're just interested in solving the equation 1000 is equal to 200 plus 3200 times 0.7 to the power of t. Right, that's because we're trying to find when will the value of the computer be 1000. So we have 800 equals 200. No, that's not right. I'll just do the magic eraser. Hang on. All gone. Right. 800 is equal to 3200 times 0.7 to the power of t. So I take the 800 and I divide both sides by 3200. So that gives me 0.25 is equal to 0.7 to the power of t. I take logs of both sides. Log of 0.25 is equal to t log of 0.7. So t is equal to the log of 0.25 divided by the log of 0.7, which is 3.886716 years. Now, one way to answer that is it takes 3.87 years to be worth $1,000. But that's not really how we talk about years. It would be better to give that in terms of months. So we're going to convert that to the 0.87 into months. Right, but before I do that, I forgot about the bad 80s pop song. So here it goes. First person to send me an email gets a chocolate fish. Logan won the first one for the last video. So Logan, let's see if you can manage it again. Okay, so back to the problem. 0.87 is 10.44 months. So our answer here is 3 years and 10 and a half months, or 10.44 months, which still sounds very odd, but it sounds better than 3.87 years. Okay, thanks for watching. The next video will contain answers to questions 4 through 7.